mentioned, my work is really related to water and water quality and water treatment with particular emphasis on small water communities or small community systems. First, I want to start with the fact that what is the issue we are talking about with small and First Nations community waters that are remotely located? Well, some of you may have seen this report that came just a couple of weeks ago. Just last month, it was published by Council of Canadians. A version of this report also has been issued or has been around for actually a number of years. A map like this you might have seen, again, either this one or a version of this in the past. And so what the issues that we are talking about are around boil water advisories, that many communities in Canada, across the country, face boil water advisories. And these are, of course, number of advisories in each individual province. And in here, excuse me, you see the list of advisories in First Nations communities. So in fact, when I started working in small community water supplies about almost 8 years ago when we started thinking about those, and even about 6 or so years ago when we had our network established, the number of boil water advisories have not changed. In fact, at the time, I exactly remember it was around 1,700, and this is 1,800. So really, we haven't come any further, and that's not good news because we have been, as part of our network, which really focused on a small water supplies, we've been trying to promote the idea that we are making an impact. And if the impact means that nothing has changed, probably no impact. So that's not a good news and nothing to be proud of. It means that we haven't really gone any further. So just let's look at these are a little bit dated numbers, but really, as you have seen, nothing really has changed in the past little while. So let's look at this table that shows boil water advisories in different provinces and at different times. So these are different provinces that we have, and these are number of days of boil water advisories that you see. And of course, it shows that how many communities had 1 to 10 days of boil water advisories and so on. And of course, if you look at British Columbia, the number is actually quite staggering. It's quite high. So the number of boil water advisories are generally high in British Columbia, as you've seen in the previous map as well. But also, some of these advisories have been around for many, many years. And in fact, many communities are under permanent boil water advisories. So why do we have these issues? I just want to go through some of these issues. Many of these are trivial and probably you know, but probably it's good to put them all into perspective. One is that many of our communities, because of the way Canada is, the geography is, they're remotely located. Even in British Columbia, when we have much higher number of boil water advisories, because the remoteness of the communities as well. So a lot of communities are either located far north that they are not accessible by road, or they are in islands that they don't have any way to reach outside. They don't have a lot of power and all those kind of things. So that's one issue. Another one is our climate. There's no secret that really we have cold winters, and that climate really affects significantly on communities to have proper water treatment or proper management for their water. And that could affect in variety of ways, but just one statistics or one set of data that we've gathered in the past several years from one particular community, you see that the impact of climate or the weather on the cost of treating the water. And you can see that in the winter months, the cost is generally much higher than in the summer months. is no secret. And the reason is just simply heating the room that the water treatment system is located. Just heating cost of that particular room is going to double or triple the cost of treatment for the community. And often, I mean, this is only from a cost point of view and heating, but there are so many other issues. When the winter arrives, the roads, if there are in existence, they are going to be impassable, so that nothing can reach those communities, and there are issues associated with that as well. Population, many of our communities are very scarcely populated. In British Columbia, we have somewhere between 3,000 to 4,000 water systems. And by definition, each water system means that if a system is supplying to 2 households, it's considered as one water system. Or if it's providing water to a public system, gas station in the middle of nowhere, or school or anything, that's considered a public system. So we have a really large number of water systems in the province, and out of those, about 90% are serving these small communities, scarcely populated. Only 10% are serving large metropolitan areas or large communities such as Vancouver, Victoria, Kelowna, and so on. Capacity is a general word that I have. It's in general economic capacity, resources, and all those kind of things. So often you hear about the fact that communities don't have the funding or money to have the proper treatment or proper management. That's one part of it as well. But also in terms of operating capacities as well. These communities don't have the expertise to run or maintain any treatment systems. Often they rely on volunteers with very little expertise to run their water systems. Just to give you a little bit of a statistics, this is again a little bit old data, but still relevant. Up to of about 1,300 or so water operators in the interior BC, 75% had no certification. So they had no expertise in running water treatment systems. Only 100 of these, so basically less than 10% or so, had certifications that was lower than what was necessary for the type of treatments they had. And only 230 or so of them, 20% roughly, had appropriate level of certification. So really, a lot of these communities don't have proper staffing. And when they don't have, their communities, of course, suffer with any treatment that they have. No matter how much money they have, or whether government gives them money or they gather from themselves or whatever, they don't have the capacity really to operate these treatment systems. After a while, they fail miserably, unfortunately. Perception this is another very significant barrier to having proper treatment of the water. When we talk about perceptions, there are 2 aspects to it. One is that people say, okay, well, why do I have to treat my water? Especially when it comes to asking them to pay for their treatment system. And now, out of their pocket, they need to pay a certain amount of money or tax or whatever that is to install a treatment system. And they say, why? I've been living in this particular community. I've been drinking this water. I never got sick. Why should I have to pay to have a treatment system? So that's one aspect of it. The other aspect of perception relates to some communities that do not like chlorine. So if a particular treatment system which involves adding a chemical, in this case, the most common one being chlorine, is added in the water, some communities reject or some people reject. Naturally, if I come to you and say, okay, well, do you like to add chlorine into your water? Nobody says no. Nobody says yes. So everybody says no. And the same thing exists. When you tell these people, to the communities that have been, again, drinking their water without any problem or without apparent problem, they say, well, why we should add chlorine into the water? It's not necessary. And that causes some resistance, and significant resistance, particularly if there is a taste of chlorine remaining. If they add chlorine in the water and nobody tastes it or they don't taste it, that's okay, because they don't see, they don't feel, they don't smell, that should be okay. But as soon as they smell or taste the chlorine, they start to dislike it, and that affects how they perceive it. So in First Nations communities, for example, this is very strong. There is a lot of resistance against chlorine. This is added not only because of the taste, but because when they see some chemicals are added, and because they consider water as a gift from Creator, it's sacred, it's pure. When you contaminate the water with a chemical, is not a good thing. So that's one resistance that exists. Regulation is another very important challenge, very important barriers. We often don't think about that as an issue. Just to give you an example, in British Columbia, this is the regulation, what it calls. It says 43210 rule, basically. And what it is that they say any water system in the province should meet this rule. And that what it means is that it should give 4 logs of removal of virus. Means that 4 order of magnitude, 99.99% removal of viruses. The treatment system should also provide 3 logs of removal of parasites, Cryptosporidium and Giardia. So it will be yes. Yes, that's a very good question. So the question is that, well, how about if there are no viruses? Well, in fact, often there are no viruses in the water. But the fact is that this is a precautionary point, means that this water, if there is a risk of contamination, because nobody goes and checks the water for virus and Cryptosporidium. These are expensive techniques. So the condition is that if, or the rule is that if there is any contamination or the risk of contamination, the treatment must ensure that you get that much reduction of the viruses and parasites. So your treatment technology that you install should have the capability of, or should have a proven record of removing these particular pathogens. The third objective is that you must have 2 barriers, meaning that 2 types of treatment you should have, so that in case one fails, the other one is there. The fourth one is 1 NTU, that's a turbidity measure, or measure of cloudiness of the water. So your water, your treated water must be less than 1 NTU. So if your water is a little bit brownish or murky, is not acceptable, because there is always risk of some pathogens or some bacteria associated with these particulate matters that are in the water. And finally, there has to be 0 levels of E. coli in the water. So it's a very elaborate objective. And now think about a community of 50 people. For them to have a treatment system that meet this requirement is, in many cases, impossible. It's going to be very costly. It's not going to be that achievable. So what's the choice is that they will do nothing and will go under boil water advisory. Another thing is about the monitoring aspects, that Ministry of Health requires that every community less than 5,000 people must send their water for tests every week on a weekly basis. Now we have 3,000 water systems, many of them very small. Now think about them analyzing their water on a weekly basis. That really doesn't happen. So already many communities don't meet these requirements. So I know that there is a lot of discussions around reviving or changing the Water Act, but this is what the current rule is, and that's certainly an issue that many communities fail and cannot really meet that requirement. And finally, technology. Technology often is considered that is not an issue, but I want to argue that in fact is an issue, because technologies that are utilized in many small or are proposed to these small systems are often not suitable for those. I'll just give you one example. So it's a story of one First Nations community. It's about 3 hours northwest of Prince George. There are 10 homes in the community, 20 to 30 people maximum. In some times of the year, there are less people involved in there. The nearest community is 60 kilometers away on gravel road or logging road, and they are next to a river, basically. So a large river with fluctuating water quality. So that's how this community, or where it is, and what is the conditions around that. So what is the solution? So this is the river that is next to that community. So if you want to provide this water for the community, one is that we treat the river water. The second one is, okay, well, forget about river water because the quality changes and there are possibility of biological contamination. So we go to the groundwater, dig a well, and use the groundwater instead. But the issue in this case is that there is a slightly elevated level of arsenic in the groundwater. So we can't really use the groundwater as is. There has to be some treatments. So the alternative would be to truck the water from nearby community 60 kilometers away on a weekly basis to supply the community with water. Fourth one is, of course, do nothing. And that do nothing means that you have boil water advisories. Even the third one means that you have boil water advisory, but okay. So when the first time engineers tried to see or look at these 4 options, they said, okay, well, do nothing is not a good option. This trucking the water, which is currently the current practice, is costly. In winter time, you cannot access the community, and that causes a lot of stress, a lot of uncertainty, and all those kind of things. So what about digging the well? So they said, okay, well, probably it's better than treating the river water. So they went and dug the well, and as soon as the word got out that there is a little bit of arsenic there, so community members went and put something, a tree trunk or something, into the wellhead, and that ruined the entire effort, basically. So they send a message that we don't want this particular well water because it has arsenic in it. And that goes back to the fact that the engineers, when they chose this path, they even didn't really communicate with the community members or the members that, okay, well, this is possibility and we want to consider that, and we are still going to treat that one. So without any consideration, they went and dug the well, and that failed. So the next alternative was to treat that river water, and they went actually did that, and they hired an engineering consulting firm, very reputable one, a seasoned engineer. It was in fact in charge, and what he proposed for this was a very super sophisticated membrane technology. When I went and visited this plant, when I looked at this system, I got a headache. I couldn't really see what is what. So think about it, a community of 10 to 20 people seeing this, are they able to operate? No. And as a result of this, after about less than a year of operation, the system fails and is still sitting there. It's a junk after 9 years and is not going to do anything. And community is back to boil water advisory. And it's actually a source of a lot of frustration for people. They say they came and they did something without really considering what we need and all those kind of things. And that caused a lot of issues with that community. So what I was going to get at is that yes, there is a technology, and so is the technology to treat the water or reuse the water in a space station. But can we use that technology in a very small and remote community that they don't have the capacity? I think that's something that we do not consider that. So certainly there is a lot of need for considering proper technologies or even developing proper technologies. So you may say that, what about point of use treatment systems, which you can install it under your sink and it provides a clean water? It's available. Many developing countries have those. Well, my answer is that point of use is probably not the best option, because still you are not going to be off boil water advisory, because it provides only clean water to your sink. What about in other areas in your house? If there is a kid or someone goes and then drinks that water. So still the regulation or health authorities are going to call for boil water advisories. So the better option would be point of entry, meaning that all the water that comes into your house will be treated. So what we did, we went back and then analyzed or reanalyzed to see whether there is anything that could be, or any advantage of using this. Purely from a cost point of view, what we did notice is that for this particular community, if we are, over the life of the project, which was about 20 years, lifetime of the system to be installed, if you're below about 35 to 40 households, your point of entry is going to be a lot cheaper or a lot more economical. And that includes the cost of operations and everything. So considering that you pay for everything, all those sampling requirements that are meant for by the regulations, it's still going to be a lot cheaper for them. Now, so if you go back to those, yes. Yes. Yeah. So that's actually part of the requirement. If you look at this list, I have a question mark in terms of regulation. Regulation calls for, if you have point of entry treatment systems, every household, every treatment system should collect water samples. And that means a lot more operational cost associated with it. You need to send samples to be analyzed. Somebody needs to go and check in terms of maintenance and all those kind of things. So considering even those cost aspects, still it became cheaper over the life of the project. So however, if I look at this one, there's certainly some aspects that could be easily checked, basically, that we meet or address those challenges. But I have some question marks around these. I think the most of it is around operation. Is that, do you have still someone properly trained within the community or somewhere nearby to go once a month or once every few months to check these systems to see whether they are working, they're not failing? I think that's the key aspect. So limitation still exists. This limitation could be addressed by having the technology in a way that is robust or remotely monitored and controlled. So you don't have to rely on one particular individual in the community that is not trained to go and do all these monitoring and all those kind of things. So if basically there are robust and reliable technologies or remote monitoring, you could get away with the operation issues and the regulations issues. So why I have regulations in terms of question mark is that if you don't have proper maintenance or proper monitoring, still regulation is not going to call for your community to go off boil water advisory. So there are some requirements to for improved technologies or monitoring associated with these. So is there any other alternative? Or what about communities, at least based on our analysis, if the community is more than 40 households, that showed central treatment is more economical over 20 years? Well, this is something that we've been trying as part of our program. So if you look at, for example, community A, B, or C, and so on, currently the way it exists is that each stakeholder, whether it's a government or whether it's industry or whether it's researchers, they focus only on one aspects or one products that they're thinking of. That's not going to really solve all the problems, because you go and address one particular problem without really talking and looking at what other issues are associated with that, or what are other aspects that need to be there. So a better way is really to look at the vertical aspects, meaning that to look at whether for each community you can look at multiple components or bring all these stakeholders together to look at the issues or challenges associated with that community to be able to solve those problems. So what is the challenge with this is that, well, how can we go about to develop this model that currently does not exist? So company A only provides one service, company B provides only one service. How you can really bring them all together, or even bring government to really talk and communicate with industry or communities to be able to address this problem. So what we thought might work and could work is really to engage the communities or users of the water systems. So the more they are engaged in the process from the beginning, the better or the higher the possibility of success. And of course, get the research results from a researcher's point of view, really to go to the community, not to stay in our labs. So I'll give you one example. Earlier, I showed you the example of that digging a well that potentially had arsenic. So if the community was engaged from the beginning, the likelihood of failing that system would be less. Because, well, if you go to people and say, okay, well, we have this possible solution. Your water from this well may have a little bit of arsenic. This is the level. Explain all the health reasons to that, and explain to them that you're going to treat all of those, to address all those problems. Probably there is a lot better opportunity or chance for them to accept that, rather than just you go and parachute in the community, do something without really even consulting with them or talking to them. I think that always is going to cause failure. So what it means is really to bring this community concept, really put it in the middle, bring all the government, academia, and industry together and really work with the communities and to be able to solve. So this really crosses the technology or engineering into more of a social science or social aspects of it. And we call this concept really a community circle, meaning that really, and that came from the word or the concept from working with First Nations communities. Whenever they have issues, they form a circle, they talk to each other, they call it healing circle, and they try to address their problems or address the challenges that they have. So based on that, we said it's a community circle, meaning that there are a lot of, each of these are members of the community plus the actual community that is user of the water. So we have a circle, and the benefit of that is really that it's going to be co-creation, meaning that a solution is created not by outsiders, but also in full participation by insiders. So we've been working around this concept, focusing on some First Nations communities and even non-First Nations communities. This is Shawnigan Lake community on the island. But I'm going to talk a little bit about this particular community, Luskostene Nation, just to highlight how the approach is. So a little bit of a history around this particular community. This community is about 150 kilometers northwest of Quesnel, or 70, 80 kilometers south of Vanderhoof, which is just west of Prince George. It's not connected to grid, it's off-grid. They don't have any power. They're basically, they have diesel generators. Until 2008, they had no road, so it was not, I mean, the community did not have any road access, either fly in or through some kind of a strange, fancy vehicles that could get through. Since 2008, one forest products company built a road or forestry roads that goes through the community. Current water supply is a deep water well that has very high iron and manganese. So it's very odorous, it's stinky, and really is not a good quality. Is near a septic field for the community, and on top of that is near an ancient burial ground. So right there, there is an issue with some kind of a cultural perspectives. I mean, how you could expect the community members to drink the water from a place that is next to their cemeteries, basically. So as a result, community is on boil water advisory, and the bottled water is trucked in on a weekly basis. And this one, I mean, you might say, why they put these wells in that particular location? Why not somewhere else? That goes back to the fact that there was no proper engagement. Aboriginal Affairs, or at the time INAC, hired an engineering company. They went, and there is nothing in that particular community, so this engineering firm goes and brings all the equipment in the morning, tries to do the job, and before sunset go back. So even they didn't really see and talk to the community members without any consideration. So hundreds of thousands of dollars were spent on these wells, and nobody's drinking these waters. It's a great location. It's picturesque community. This is the summer time. This is the winter time. So great. And so this is the community. This is the septic field that I mentioned. And this is the burial ground, which already is an issue. So the water wells are just south of this. So there are two issues with that. One is that it's next to the cemetery. The second thing is that the slope is going this way. Now, whether from a hydrogeological point of view there is kind of a septic field going into that water well or not, I don't know. But at least from a perception is that, okay, uphill there is a septic field, and here you have water well, so there is a good chance that all your sewage is going to go into the water. So these are the issues. What we've been trying to do, based on the request of the community, we went and talked to them. So we've had multiple visits. We've interviewed their elders to really see what are the issues, what are their feelings, and all those kind of things. So a lot of engagement, basically. And this is already viewed very positively by community members. They love it, and they welcome our students whenever we go there. And we try to involve government and industry. We say, okay, you need to also be on the table. You need to listen to what these community members are telling us in terms of the water. And then there are other sources around. There are lakes, there are creeks there that could be considered as a source. So we've started collecting water samples from those and really trying to understand whether there are any alternative sources that are better than existing wells. Student design project, we engaged our students to participate in the design, and really both educational aspects for our students, but also it's good for the community because they see a group of students working or helping them, rather than industry that does have some other potential benefit. And then pilot treatment evaluations. So I'm going to focus on these two, or show these ones. So last September, we got our students. 7 of our students got interested into this, and they started working on designing water treatment systems or looking at alternative treatment solutions. So they actually went to the community. They spent some time in the community. They slept there, and they felt the stinkiness of the water. It was so bad based on their experience that they could not even take shower. And at that time, they really felt that what the community is feeling in terms of how much resistance is against them. And then they went and collected water samples from various multiple locations around the community just to see what are alternative sources that exist. So since last September, they have been working on their design, and in fact, today is the time that they are actually submitting or showcasing the outcome of their design. This afternoon, they are actually presenting their results. We also have this water treatment system on the wheel, basically. So it's we call it mobile water treatment pilot plant that can be shipped or can go from one location to another location. This particular one was being tested in Lytton First Nations, which is just north of Boston Bar in Fraser Canyon. So this type of water treatment system, which contains multiple treatment options in it, can be moved or will be moved to different communities, including this particular one, to try to see how their water can be treated based on that particular situation or the water that they have, or what type of treatment options that exist in this particular trailer can be suitable. In addition, this is used for outreach and also orientation of water operators. So while we have these pilot systems, the water operators are there, they can see how it works, and they can comment and they can view whether this particular piece of technology is something that they feel comfortable about it or not. And in fact, what we did, one example, when this system was being tested or evaluated in Lytton First Nation, there is one process called ion exchange, which really works based on exchanging ions, including nitrate or some ions that are not desirable in the water, to be removed. However, what it requires is that it requires some regeneration of ion exchange once in a while, once it's saturated. Now, the operators of this particular community told us that, well, we don't feel that this is something that we are comfortable. We don't feel working with these, and we feel that if it's there, it's eventually going to fail. So that helped us really to remove that as one of the options for this particular community there. So the result of this type of approach, really this is for Lytton. We used the pilot testings that we did. We actually went and built a water treatment plant for the community without that ion exchange component that I mentioned. And this is now being installed in Lytton. So you see that this is a trailer that inside there is this packaged treatment system with all the components being shipped or being transferred to the community. And these are the team of people who have been involved in this. This guy, Jim Brown, is an operator at the community. This is a guy from industry and some people from industry who actually helped us to put this together. And we have one of our students also involved in this. So it's really been stakeholder groups working together to really come up with eventual final product that can be installed in the community. And we hope that the same kind of approach can be applied to this particular community, Klaskus or Luskustene Nation, once the initial phase of the student design project, everything is completed as well. So, is there a solution? I'll leave it to you whether there is a solution for small water systems. Certainly there are aspects that we could look for in terms of having a solution. But in my take is that even if there is a solution, it has to be considered on a case-by-case basis. We can't apply a cookie-cutter approach to a small communities. We can't just say, okay, well, this is a technology that we can just have it parachuted to different communities and test it there. No, their situation is very unique. Each community is unique, and we need to evaluate that. And I just want to emphasize the fact that it's actually more important for a small communities to have a case-by-case look at their problems. Think about it. In city of Vancouver, how many of you care where your water comes from, or what type, more importantly, what type of treatment is involved? Very few. But particularly, nobody consults with you, and many of you don't care what type of treatment is applied. You rely on certain groups of engineers or some certain group of people who do this properly. But in a small community, it's different for two reasons. One is that everybody knows one another, so people know each other and know their water systems, everything. So they want to know what's happening there. That's one. The second thing is that whatever they do in their water, the impact is on their life is going to be huge because they have to pay from their own pocket. So suddenly they are going to receive a bill for, I don't know, $1,000. So they want to know what's happening there. So I think that's very important for small communities to have the community members engaged, whereas in large cities probably is less so important. And that comes back to the fact that it has to be community-centric. You need to have community engaged, and really, hopefully with that, the problem is going to be less. I don't think it's going to be resolved completely. I think probably 10 years later, if we reconvene, number of boil water advisories in Canada probably is not going to disappear. So it's not a good ending, but hopefully we all can work to address this problem bit by bit. Thank you very much. Boil water advisories are issued for a variety of reasons. One is that if you have, for example, a surface water that is not treated, you're going to be on boil water advisory because your water is under risk. So that's one. The second one is that, yes, if you have a treatment and you still monitor it and you find that you have E. coli in your water, in your distribution system, you're automatically going under boil water advisory. So it could be ordered under a variety of reasons. So not all is because you find something. It's just because sometimes it's precautionary. Well, certainly there is no federal regulations on water, so each province has a certain thing. But I would say BC is a lot more lax in terms of their water treatments and so on. Like Quebec, for example, requires every system, if it's surface water, to have a filtration system, whereas in BC they don't. So yes, the reason, or different provinces could issue boil water advisories for different reasons, depending on what it is, but it's not so much different, really. If, for example, in Quebec, your water does not have any filtration, surface water, they don't consider the treatment being adequate. So you may be forced to have boil water advisory. From my point of view, no. Yeah, I think this is what I feel, that regulation should be a little bit more flexible when it comes to small systems. You cannot apply the same regulation or the same regulation that you apply to City of Vancouver to a very small and remote community. As long as it doesn't impact the health of the population, I think that's important. No.
We found that there was a correlation. I did this a little bit ago, about the same time that you started. I did this for around the Vancouver area. And we found a correlation between Fort, whatever it's called, Langley. Because Fort Langley is actually a great example. A lot of it has got groundwater and septic tanks and everything else, and the rest of it is on the grid.
Yeah.
And you can compare GI incidences in Fort Langley in the region that is well water supported versus grid supported. And you can actually see some of that, but elsewhere,
No, actually, I spoke to someone from BCCDC. Um, they receive samples or even incidences of GI or anything. She wasn't able to give me any response in terms of whether there has been any correlation found with that.
I have to get the data on,
Yeah.
on a case-by-case basis to look at this.
Yeah.
I wanted to ask you to find out since the economic capacity of these communities. I think the cost of water treatment is so prohibitive for so many of these communities that average users does not provide enough resources for these communities to meet these expectations. So I'm wondering what your thoughts are on that in terms of just mobilizing resources from GI researchers, but also, I guess, a follow-up question to that is the mobile treatment facility that's present, so I think there's the one up in the truck. How much does that cost to maintain, is that viable?
For this particular Lytton, it's 6 homes, so it's not very large community. 6 homes, and a few years ago when they were trying to address their problem, they approached engineering companies, and the quote or the price were given to them was $1.3 million. Now, one thing I should say is that engineering companies, when they see a First Nation client, their prices are inflated significantly because they know that the funding for those projects come from the government, so people don't pay from their pocket. So they say, okay, well, here is an opportunity for us to get everything out of government. Now, when we started working together with these, the same company approached them and brought their price according to the operator, Jim Brown, brought their price by $900,000 down. So the 1.3 million became suddenly $400,000. Why? I don't know. But what was the cost of this particular package treatment system in place? Just over $200,000 installed. Basically, it's called turnkey, everything. So it's prefabricated, installed, and coming to operation. Now, again, the issue with First Nations communities is that when the consultants are involved, they also get quite a bit of cost or money associated with that. Generally, engineering cost or consulting engineering cost for a project associated with First Nations is about 20%. For typical projects, engineering costs should not be more than 10%. So that already says that engineering firms also get quite a bit and inflate their prices. I think even though the situation in First Nations communities is really not good and many communities have issues, but I think when it comes to capital investment, they are in much better situation than non-First Nations communities. The reason we hear a lot more about First Nations communities because it's politically more sensitive, so it gets, the issues around them gets a lot more visibility. But non-First Nations communities have the same challenges, but they don't have absolutely no funding support for them. There are municipalities, if they are incorporated municipalities or part of regional district. There are many improvement districts, they call it. I mean, these are different ways of governance, which I'm just learning. Like I'm working with one improvement district that has a population of about up to 500 people. They have absolutely no access to funding, provincial funding. So they are working, they are on boil water advisories, they're trying to work with us, and they have to come up with their everything from their own tax money. Well, we have both consulting industries or industry partners involved, and also engineering or water treatment providers as being our partners as well. If you want to name, I can give it to you, the names later. But I mean, there's no secret. If you go to our website, all the names are there. But I think I can certainly provide you with all the details around them. You mean just simple filtering with gravity-based filters? Yes, it does work, and it is effective. The challenge with that is there are two challenges with these very basic treatment systems. One, one is more of a social challenge. We are in a developed world, in a developed nation, and the people who live in the communities, they are still feeling that they are part of the developed world. It's very difficult for them to accept a technology that is now being utilized in Africa or places like those jugs of filters that you can just drain the water through them and those kind of things. Very basic, but very effective. So that's one issue associated with that. So people still in these communities, they have satellite dishes, they have mobile phones, they have fancy trucks and all those kind of things. So for them to accept a very low grade, or in terms of the appearance, very primitive technology, they feel that they're not getting the value for themselves. So they need to see some level of sophistication in technology. So if we can package the treatment, these gravitational filters, in a more sophisticated way, it's probably is going to go better. That's one. I think another aspect is the regulation as well. Is that how to maintain, how to ensure that it provides you all the consistent results and all those kind of things. Regulation, I mean, health officers who eventually approve the treatment systems, they, unfortunately, they look at certain criteria that were given. And if the technology is not approved by EPA or National Sanitary Foundation, NSF, they don't accept it. So there is some kind of a resistance from the regulators as well. Yes.
I didn't understand. You mentioned the 4B. Is that for all BC?
It's for all BC, yes. Yeah. Is that the treatment option should meet all those requirements.
Nanotech sand in our gravity system.
That's right. Yeah, it's just make it a little bit fancier. Yeah. Yes.
Rain harvesting, precision harvesting, you didn't mention that at all.
No.
And it's not an option that's on the table, or why?
Well, it could be an option, but as I said, with all of these, you need to overcome the regulatory barrier. And the regulation needs to accept that technology as a viable source, or as viable technology.
Now it's not allowed. I mean, clean and dirty surface water is much harder to
Yeah, I do agree. But you need to make sure that this rainwater is monitored this with the same level of monitoring requirement, meaning that on a weekly basis should be sent for monitoring and somebody collect water samples, all those kind of things. If you can meet all those requirements, then it will be acceptable. Otherwise, it's not going to be acceptable. So as I said, regulation is a major barrier in many aspects. Yes. It's interesting question. I'm not a social scientist and so on. So, however, I had a very motivated graduate student who undertook this challenge of really talking or surveying, interviewing water operators from across the province, from First Nations communities, and really talking to them to see what are their issues, what are their challenges, what kind of support mechanisms they have, and all those kind of things. So one of the final conclusions that came was that there is a need for some kind of a water operators, if we call it association or group, that can provide mentorship and support to each other. And we put this forward to Aboriginal Affairs, and they are seriously considering in supporting that kind of a group mentorship. Yeah. So there is, yes, to answer your question, I think getting support from from communities nearby or from generally other First Nations communities is very much valued by First Nations, because they trust each other a lot more, they know each other, they can speak the same language, not really in a literal way, but in terms of what are their issues and what are the challenges. Yeah. Okay. Thank you very much.